Good day, welcome back grade 11s. We are looking at video 3 of Exponents and Surds. Remember that this resource is copyright protected. So our exercise that we have today is the fourth root of 16x to the power of 4 over the square root of 25. Right, step 1 tells us we must write everything in prime base. Once we have it in prime base, now we can get rid of the surds. Surds, whatever the index or index is of the surd, that is what we have to divide by. So we divide by 4, we divide that 4 also by 4. The index for this surd is the square root, so that's a 2. Therefore, we divide by 2. So, our answer for this one then comes to 2x over 5. Now we get to our next exercise. We're working with equations. So here we have 3 to the power of x plus 3 to the power of x minus 1 is equal to 12. Whenever we have an equation, something needs to be solved. We need to calculate a value of the unknown. So what we do here is we will firstly try to make this a single term so that we can do some isolation of the unknown. Here, 3x is a common factor. So we firstly break this one up as 3 to the power of x multiply with 3 to the power of minus 1. This is equal to 12. Our next step now is we take out the common factor, which is 3 to the power of x, multiply with 1, and multiply with 3 to the power of minus 1. But 3 to the power of minus 1, written as a normal number, would be a third. 1 plus a third will give me 4 thirds, or it will give me 1 and a third. So how do I get rid of 3 to the power of x multiply with 4 over 3? I will multiply with 3 over 4 on the left hand side, and I will multiply with 3 over 4 on the right hand side. Meaning I've got to multiply with the reciprocal of 4 over 3. Once this is done, I can simplify and say this is equal to 9. Next step is to say that this needs to be written in prime base. The prime base for this is 3. 3 to what power? That's right, 3 to the power of 2. Now, because the bases are the same, I may equate the exponents. Therefore, x is equal to 2. Do not make the mistake of cancelling out the 3's. There's no such thing. Because the bases are the same, I may equate the exponents, meaning write it as x is equal to 2. For this one, just a reminder, remember that any number written to a negative power must always be written as a positive power. And how do I write something as a positive power? I say 1 over that number to the power, and then the power becomes positive. Goes back underneath the line. So my answer 3 to the power of 1 is 3. So therefore my answer for 3 to the power of negative 1 is a third. Also remember, when I work with a fraction to a negative power, the fraction is being inverted because of the negative sign. Because now negative 2, that 2 to the power of negative 2, that 2 to the power of negative 2 will go underneath the line and become positive 2, and 5 to the power of negative 2 will go above the line and become positive. We all know that when we have a power raised to another power, we will multiply those powers. And because it is negative, we take it to the bottom of the fraction and it becomes positive. So 5 squared is 25, 2 squared is 4, so my answer is 6 1/4. You can try to solve this one on your own. See if you can manage to get an answer for this one. And if you do, well done to you. You can press pause and then reveal the answer once you are done. Right, if you followed the following steps diligently, you would have come up with the following. You would have said, divide by 3 on this side, divide by 3 on this side. Now you only have x to the power of 5 over 4. Your next step, multiply this exponent here by 4 to get rid of the 4 underneath the line. And also write this as a prime base. 2 to the power 5. Multiply the left hand side also by 4. So now I get 2 to the power 5 times 4 is equal to x to the power 5. Then I divide by 5 on this side and I divide this by 5 on this side, meaning exponents, or rather saying multiply with the reciprocal, which is 1 over 5. Same on this side, and the 5 will be cancelled out. I'm left with 2 to the power 4. Therefore, x is equal to 16. Thank you for watching this video. Hope to see you in the next one. Goodbye.